Hello everybody. In this video series, we're going to see interesting integrals for early calculus students. Our first integral is cosine squared of x from 0 to pi over 2. Actually, we're going to find the antiderivative of cosine squared of x, and we're going to try a few different variations. For this integration, we need to know double angle identity. So, double angle identity for cosine x is equal to 1/2 1 plus cosine of 2x. So whatever angle we have here is doubled here. If we had here 2x cosine squared of 2x, then we're going to have here 4x. If we have here cosine squared of 3x, then we're going to have cosine squared of 6x. So whatever we have here, we are doubling. Now we're going to start by substituting cosine squared of x with the double angle identity, which is 1/2 times 1 plus cosine of 2x. And we can pull 1/2 in front of the integral sign and write 1 plus cosine of 2x inside of the integrand. Now we can separate this integral. So we have 1 dx plus integral of cosine of 2x. We know how to find antiderivative of 1 with respect to x, which is just x. From lower boundary to the upper boundary. In our case, from 0 to pi over 2. Here we can use u substitution. Let u be equal to 2x. Then du will be the derivative of 2x, which is 2 dx. And if we solve for dx here, we're going to have 1/2 du. Now let's write everything in terms of u. So it's going to be, instead of cosine of 2x, we have cosine of u. Instead of the x, we're going to write 1/2 du, that we can pull 1/2 in front of the integral sign, and du here. Now we know antiderivative of cosine of u. So this is a practical way to find the derivative and antiderivative of trigonometric functions. Cosine, negative cosine direction, sine, and negative sine direction. If you go to clockwise, you get the derivatives of each trigonometric functions. So this is the derivative part. And if you go to counterclockwise or anti-clockwise, then you get the integrals. So integral of cosine is sine. So it's going to be 1/2 sine of, instead of u, we can bring u back, which is 2x, and from lower boundary to the upper boundary. And we had x here from lower boundary to the upper boundary, and 1/2, that is multiplying the whole term. Now we derive the antiderivative of cosine squared of x, that we can plug in any lower and upper boundary. In our case, our lower boundary a was 0, and our b was pi over 2. So here we have, instead of x, we plug in pi over 2, and again, instead of x, we plug in 0. Upper boundary minus lower boundary. Plus 1/2 times, instead of x, we plug in pi over 2, minus, instead of x, we plug in 0. Sine of 0 is 0, and sine of pi is also 0. On the unit circle, if we check pi, which is here, the y-coordinate of this point is 0. So sine of pi is 0. So what we're going to obtain from here is 1/2 times pi over 2, which is pi over 4, is the answer for cosine squared of x. From 0 to pi over 2. What if we had from 0 to pi of cosine squared of x? Let's use the antiderivative we derived, which is 1/2 times x from this time 0 to pi plus 1/2 sine of 2x from 0 to pi. Upper boundary pi minus lower boundary 0 plus 1/2 times, instead of x we plug in pi, and instead of x we plug in 0. Sine of 0 is 0, 2 times pi is 2 pi, and 2 pi is 1 full rotation, and here, so y coordinate of this point is still 0. So sine of 2 pi is 0. So this whole term goes again. This time, from 0 to pi, our integrand will be pi over 2. So if our boundaries were from 0 to pi, then our answer is pi over 2.